In this video, I'm going to help you to understand probability distribution with a common game known as craps. This is a game played with two six-sided dice. And if you've ever played this game, one thing you notice is that you're going to have different odds based off of what numbers you're placing your bets on. And the whole reason for those odds changing, why is it different for you to be betting on a 4 versus a 7 or 6 or an 8? Okay, it's because your probability distribution is significantly different in those scenarios. Okay, so what we're going to look at here is this chart. We've got two six-sided dice. So what that means is that we have 36 possible combinations. Okay, and out of those 36 possible combinations, we want to ask ourselves, how many different ways can we get a sum of 2? Okay, so if we're thinking about rolling two dice and we get a sum of 2, there's really only one way that occurs, and that's rolling snake eyes, 2 ones. Okay, so there's really only one way of this occurring. Now, if we think about 3, we can roll a 3 by rolling a 1 and a 2, or vice versa. We could flip those two dice, and the other one could roll the 2, and the one that rolled the 2 previously could roll the 1. So that's going to have two different outcomes. Okay, now 4, we can roll 2 2s. There's one scenario. We could roll a 1 and a 3, or you could roll a 3 and a 1 if you just flip-flop those dice. So that's a combination of 3 different outcomes. And it's just going to consistently rise as we go down 1, 2, 3. There's going to be 4 outcomes for 5. There's going to be 5 outcomes for 6. Now 7 is the most likely scenario to happen. 7 can be rolled by a 1 and a 6, a 2 and a 5, a 3 and a 4, flip-flop the 3 and the 4, right? There's a lot of different ways that 7 can occur, and that's why 7 is the dice, the roll that you actually don't want to be hitting once you enter the game of craps. So if you know anything about the game, once you enter the game, 7 is wanting to be avoided, but it's difficult to avoid 7 because you're most likely to be rolling a 7. Does this make sense? So I'm going to fill out this entire table. It would look like this. Now, when we go to 8, we're going to come back down from 5 to 4, 3, 2, and 1. If you think about it, 12 can only be rolled by a 6 and a 6. There's only one possible way for that to happen, so the likelihood of it happening is much less likely than rolling an 8 versus a 6 or a 7. Okay, so now over here, what we're going to be looking at is our probability X. So if you think about this, 36 possible combinations, there's only one outcome where this can occur, so our probability is going to be 1 in 36. We have a 1 in 36 chance of rolling snake eyes and getting 2 as our sum. Now with 3, that's a 2 in 36 chance. So you could say 2 in 36 chance, but that's really equivalent to 1/18th. So you have a 1 in 18 shot there. 3 is going to be 3 in 36. That's going to simplify down to 1/12th. You have a 1 in 12 shot of rolling a 4. Okay, now when it gets to 5, this is where we get into the heavier dose of it, right? So we got 4, 36. That's going to simplify down to 2/18, 1/9, 5, 36. And then we got 6/36. So that's a 1 in 6 chance. It's a 1 in 6 chance of rolling a 7. Okay, so if you can stay on craps without crapping out, okay, you're rolling, you're the shooter, you're the one trying to avoid a 7, you don't want to crap out, you have a 1 in 6 chance of hitting that 7. So if you can avoid it for more than 6 tries, like keep on rolling, baby. I'm going to jump on that table. Okay, and then we go back down, we're going to be at 5 in 36. We're going to 1/9, 1/12th, 1/18th, 1/36th. Okay, so now that we have our table filled out, we can go over to this chart and we can create a graph that's going to represent this data, this information, to show you the likelihood is going to rise in the center. These numbers right here are your most likely to be hit. Okay, now that I got some information down here, I listed down the numbers 2 through 12, which is our possible sums. Over here I have our lines. We've got 1/6, 1/9, 1/18th. This would be 1/36 or 1 in 36 chance. So let's go to 2, which we had a 1 in 36 chance. We can just do a quick bar going up, show where that goes to. And then you're just going to keep climbing. Each one would go up to the next line, showing that our odds are increasing. So I'll take care of filling out this chart, and then we can explain what it's actually saying to us. So when looking at this chart, one thing you're going to notice is that the tallest bar is in the center, 7. That's because 7 is most likely to occur when you are rolling 2 6-sided dice. That's the number that has the highest probability because there's more combinations that you can create from 7 than you can from a 12 or 11 or 2 or a 3. Again, one more thing to just think about. 2, the only way you can get that is by rolling 2 1s. There's only one possible way of that outcome happening. 12, the only way that happens is if you roll a 6 and a 6. It's much more likely you could roll a 4 and a 3 and get 7, or maybe you roll a 5 and a 2 and get 7, or maybe you roll a 6 and a 1 and get 7. There's so many combinations that create 7. That's why its probability is the highest. 6 and 8, these numbers, they're going to have a high probability as well. And the farther you go out from the interior of these values, right? So going from low to high in numerical order, the interior, the center, the median, that's going to be your highest probability. And the farther out you go, the less likelihood you have of rolling that number. Okay, that's why you see your odds the way you do in the games such as craps. You're going to have low odds with 6s and 8s, high odds with these lower numbers and higher numbers, 10, 11, 3, and 4. Hopefully this makes sense. It's all a mathematical game. Understand your numbers, study hard, and good luck on your upcoming test.